Hello, in this video, let's discuss next question in DB on trees. The question says that we are given two different trees, and our goal is to add one edge that connects a node in each network to minimize the maximum distance between any two nodes. Determine the distance. Given that one new road for undirected edge connecting one of the places in the network A and another in network B is to be added in such a way that the maximum distance between any two different nodes in the new network is minimized, and find the minimum distance possible required distance, and the constraints are n is up to 1 if the both nodes in the both trees can up to be 1 if. So for example, what the question is saying, so these two are the given trees. We can select any node from the first, we can select any node from second, and then we can connect a new edge between these two, and after adding the edge we have to return the maximum distance between any two nodes, and we have to select two nodes such a way that the final answer will be minimized, and the constraints are up to 1 if. Hope you got the question. So firstly, let's think of a node from the first tree, and then let's try to discuss which node is better to connect with in the second tree for the first node. So let's say this is the first node, and we are trying all the four possibilities in the second tree. So first one, second one, third one, and fourth one. So if we are connecting an edge between these two, then what will be the maximum distance in the new tree? It will be 1, 2, 3, 4, 5, 6, 7, because the diameter. Hope you know what is diameter. In the last video, we discussed that diameter is the maximum distance in between any two nodes, and how can we find that? So in this new tree, the diameter will be between this node, and the distance will be 7. And if we connect between these both, the answer will be 6, because it will be from this and this. 1, 2, 3, 4, 5, 6, and similarly 1, 2, 1, 2, 3, 4, 5, 6, and similarly for this 1, 2, 3, 4, 5, 6, 7. So for these four cases, the answer will be 7, 6, 6, 7. So in this way, we can select all the first nodes, and we can select all the second nodes, and then we can add edge between these two, and then we can find the diameter of whole tree with O of n. So in this way, we can try to do brute force with O of n cube, but as n is 125, this will surely not pass. So for a node in tree 1, let's try to think how can we betterly get a node from second tree, instead of just trying each and every node, which will take extra of n. So let's say the second tree is skewed. Skewed in the sense it is attached to at most two nodes. So full straight path is a skewed tree. So for a first node, let's assume the second tree is skewed, and then which node is better to connect with the first node? Is it better to connect with last, or second last, or third last, or and so on? So if we try to observe more, if we connect if we connect this node and the last node, then what will be diameter, and on where the diameter will depend, on which node the diameter will depend. If we connect these two, the diameter will be dependent on the last node, because the whole skewed one, this is the present node. So if we are connecting these two, then the maximum distance between which nodes? Obviously from the last node, because this is the whole one. If we are connecting with this one, the distance from this to this will be 2, it will be 3, it will be 4, and so on. It will increase till the last node. So if we are connecting with this node, the diameter will depend on the last node, distance on the last node. So if we are connecting this between this one to this one, then the new diameter will be 7. If we connect this one and this one, it will be 6. If we connect this one, it will be 4, it will be 5. For this, it will be 4, but for this, it will be 5. Why so? Because let's take a small example. So let's assume that this is the skewed tree of the second node, second tree, and this is the first one. So if we are connecting these two, then what will be new diameter? It will be 1, 2, 3, 4, and the new edge will be 5. So 5, and same for this also. It will be 4, it will be 4 also, and it will be 3. Because if we are connecting this, the maximum distance will be simply 1, 2, 3. So if we observe that the answer is highest for last two and last two directions and nodes. It is 5 for both, and it is 4 for these both, and it is 3. So why it is reducing and increasing again? It is simply because if we are connecting with the farthest nodes, then the diameter will be increasing. But if we are connecting the middle nodes, then the distance will be reduced, because for example, this is whole diameter with, this is the whole tree with length 4. So if we are connecting with the ends of the tree, then the answer will be 4 plus 1. But if we are connecting to middle, then only half distance will be considered, because the diameter is the maximum distance only, right? So if this is the whole one and this is the new edge formed, the diameter will be simply this. So what is this? It is simply the length of tree skewed tree by 2, and this is the extra node formed. So if we are having a skewed tree and if we are having a node, then it is surely better to connect with the middle one, so that the maximum distance will be surely be halved, and it is better than when we are adding the edge between the farthest nodes. So we got a strategy on how to get the least distance when the second tree or first tree is skewed, but it is not the case, right? The tree can be anything. So then how can we find the answer? So how can we find them? So let's say this is the node, and we cannot get. So this is not a skewed tree. This is not a skewed tree. So if we connect, if, for example, let's take this node. So we got the answer for this, right? If this is the skewed tree, then we got that it is better to connect with this node. But now it is not the case. We have this node also. So now for now, let's assume that this is the node that we're adding. This is the node that we're adding edge to. So we have added the edge, we have added the distance. Then what will be answer? So even if we take a node outside of the skewed tree, the answer will be more. For example, we have a big tree like this, right? For example, we have this one. We have this tree. So diameter will be always be skewed, right? Because diameter itself means that it is the path between, it is the distance between two nodes with largest distance. So for example, for this tree, what is diameter? It is simply this one, because the maximum distance is between these two nodes, and it will be the sum of all edges in this. So if we are given a big tree, we can separate it into skewed parts with diameter. So this is the new diameter, this is the diameter of the tree. So we can make this as a skewed part, and this is the other skewed part. So now we are having a new node. So now it is simply that we are given the we are given many different skewed trees, and then we have to select the one with the largest distance, like to get the least distance. For example, these two, the whole is the new given tree, but we can separate into two skewed parts, right? Because we got optimal strategy for a skewed part. So we can simply break the given tree into diameter, and diameter is also skewed one. So indirectly we can break the given tree into multiple skewed parts, so that we can get individually our answer for every skewed part. And for example, this is the tree, and these are the two, this is the diameter and this is the left part, and even this is also skewed. So for example, this is the node that we are considering in the first tree. It is better to connect to which skewed part? It is obviously better to connect with a node in the diameter of the second tree. Why diameter? Because even if we add to any other node in other skewed part, even then the answer will be dependent on these two nodes only, right? Because these, for example, let's assume that this is the original diameter, this is the node A, and this is the node B, and these two are the nodes that are farthest apart in the given, in the original tree. So even after we got the diameter separated, and we got the other parts as well, and now we are thinking about node C. So even if we connect, for example, this D, so now we are assuming that we are having a node C, and they just the diameter farthest nodes are A and B in the second tree, and D is some other node in some other part of tree which is not diameter, which is not in diameter. And now we are thinking about C. So if we assume that we are adding the edge between C and D, even then the answer will be dependent on only A and B, right? Because these two are diameter, B, because these two are ends of diameter. So even when the new edge is formed, it will dependent on the distance from A to B to every other node in the tree, because these two are ends of diameter. And for example, we are adding this, we are adding between C and D, then what will be answer? It will be simply the, it will depend on distance from D to the node that is in the diameter in the path A to B, like which is connected. For example, this is the diameter, and this is the node that we are talking about. So in this case, what will be the answer dependent on? It will depend on simply this extra distance, this extra distance, and then half the diameter, right? So this extra distance is simply the distance between the node D and the node which is ancestor of D in the diameter. So this is the extra distance that we get, and this is the half diameter. So the new diameter will be the extra distance, the initial diameter by 2 plus the extra distance that we get. So this is the distance that this is the final answer that we get for a single node from tree, and we are connecting C to D. But what if we select a node in the diameter to the C? It will be only diameter by 2 plus 1, right? There will be no extra part. Why no extra part? Because we are directly adding the edge between the middle node of diameter, because we discussed that for a skew tree, the middle node is the best one. So for a diameter, if we directly add with the middle node with the present edge, the answer will only be the half diameter plus the new extra edge. But if we are adding the edge between any other part of the tree which is not in diameter and the node, then we are adding the extra distance also plus 1 and plus half diameter also. So hope you got why we should select only diameter. So now the algorithm is we are given a big tree, second tree. Even then the answer will depend on only on the diameter. So we'll get the diameter of the second tree. We only want the length of diameter, right? Because for example the diameter is of length 5. Is of length 5. So the answer will only be, for example, this is 5 and we are having this one. So what will be new answer? We will select the middle node. So the answer will be 1, 2, 3. So it will be simply 5 by 2 plus 1. This is only for the first node, right? So the thing we are discussing after now is for a first node, what is the better node to select in the second tree. So in this what we got. So regardless of the tree, we can just consider the length of diameter of the second tree. Why only that we discussed above? Because if we add an edge between C and any other node which is not part of diameter, we are adding extra answer, but which is maximizing the answer, but we want the least answer possible. So it is better to pair the node with C with the node which is at the half of the diameter, so that the only answer will be 1 plus half of the diameter. So we got idea how to get answer for single node. And now what is the time complexity? It will be of n square. Why n square? Because we reduced only the extra part n. Find the maximum diameter of whole tree. So this is what we did. Pick any node, sorry. This is what we removed. Pick any nodes in second tree. Because we got the optimal thing for a node selecting in tree 2. This is off 1. So now the answer is off n square. Even now it will not pass. So even now we have to think in a better way. So let's simplify this by finding diameter of second tree, and then we will traverse all, then find the answer. So now the algorithm is n square. So how can we even simplify this? How can we even reduce this? So the thing we are doing now is we are traversing every node from 1 to n in the first tree, and then we are adding the edge between the middle node and this one, and then we are finding answer. So it is better to get a node in the first tree as well as we got in the second tree, because in the second tree we are not traveling the tree as well to get the better node. So can we try the same in the first tree as well? So let's think of it. So it will be unsquared. So how to make this often? So apply the same strategy that we are applied for second tree in the first tree as well. So what is this? So let's say we have a big tree 1 and we have a big tree 2. So for any other node in the first, let's assume that this is the node that we are selecting, and this is the only node that we are considering because it's the diameter and this is the middle node of diameter. So independent of the node in the first tree, the node that we are selecting in the tree 2 is middle of diameter. So this is already fixed. This is always fixed. So the only thing depends is the maximum distance is the node that we are selecting in the first tree. So how can I do that? So we got that it is better to take the diameter in the second tree. So what if we try to say take the diameter in the first tree as well? So let's take other example. So this is the first, let's assume this is the first tree diameter and this is the rest part of the first tree. And similarly, this is the second node that it is optimal to add edge between any other node from the first tree. So this is the second node, and so we can add edge between these two, or we can add edge between these two, or we can add edge between these two. So which is better to add? So even now it is better to select the node from the first tree such that it is the middle of its diameter. Why so? Because think in the same way that we thought for the second one. For example, we are considering this node, which is not a part of diameter. So if we are connecting this two, then what will be answer? It will be simply this extra one plus d by 2 diameter 2 by 2, because we already got that how we are getting d2 by 2, and this part is sorted, so we got this part. And now what is the diameter in the first tree? It will be simply d1 by 2. It is this distance d1 by 2 plus this extra bit distance, right? Because that is the maximum distance. So d1 by 2 plus some extra distance. Extra is also exactly similar. Extra is the distance between the node that we are selecting and the ancestor of this node in the diameter. So in this way, if we select a node which is not in the diameter, this will be the answer. But what if we take the half middle node in the diameter itself? If we take middle of the diameter, then answer will be simply 1 plus d2 by 2 plus d1 by 2. Because we got that by selecting middle node of diameter is best. So in this way, instead of trying each and every node, we can simply find the diameter of the first tree and we can get the diameter of first tree, and similarly we can get diameter of second tree. So it is surely better to connect edge between these two both. So even after adding the edge, how can we find answer? It will be simply one, which is extra edge, and d1 by 2, because this is the extra distance, and because this is the new diameter, and d2 by 2. So this will be answer. We can take care of d1 by 2 or d2 by 2 on based on parity of distance. For example, so we got that we are selecting the middle of these both. So tree 1, let's assume tree 1 diameter is odd, and so if the diameter is odd, for example, we have diameter 3 and we have diameter of 2, we have diameter of 4. So we have some other node, diameter is 3 and diameter is 4. So if it is odd, then what is answer? Then we are selecting this to right. Then what will be answer? It will be simply 1, 2, 3, which will be 3 plus 1 by 2. So take some examples and think how can we find d1 and d2 based on parity, because it is simple, right? For example, we have this one. We have, if we have the diameter as 4, then it is better to simply add between middle one. So it will be 3, which will be d1 by 2. But if it is not, then we can simply add plus 1. So in this way, we got diameters of two trees, and then based on the parity, we can simply get the answer. 1 plus d1 plus 1 by 2, 1 plus d2 plus 1 by 2. You can simply get why we are adding plus 1 here based on some parities that as examples. And this one is the extra edge that we are adding. So the code is also simple. So just simply find the diameter of 1, simply find diameter of 2, and then simply return this. So hope you got this. If you have any doubts, comment below. See you in the next video.